Welcome to this call. So today we're going to discuss a topic known by many people. So this topic is about cron jobs and task scheduling. So it will be quite interesting because it's a simple topic, but it can be the hardest topic if you don't understand it. So this is a continuation of a series of events we have been holding on backend development with Node, and we have been using different databases. For now, we're using a NoSQL database, that is Document DB. The other things are the same. Been using Nest for a while now, and Docker and so on, TypeScript. And today we shall be discussing a specific part of software, backend software development known as task scheduling, uh, which if you understand it in one language, you can reproduce this to your favorite language. So that's the main goal of this. Okay. Just in case you're new, this is Kenya Data Platform user group. My name is Kevin Chomba. I'm a software engineer at Griffins Global Tech. I'm also a Microsoft MVP on web development and Cosmos DB. This is a user group we usually meet on almost every Sunday, 7:20 p.m. East African time. So um, just in case you have some folks you want them to join us, hang around us during this time to learn some few things, um, just join this user group in Meetup page. I think you should be able to catch up in our calls. So at the end of this call, I'll probably show you guys where you can get the code base and the recording of this call. Okay, so let's go straight into it. So what you're going to cover is to understand what are cron jobs, think of how we can integrate this into a system, and probably do some data modeling. We are not going to use Mongoose. I initially wanted to do that, but we are not going to use Mongoose. We are going to stick to um, the driver, the Mongo driver for writing the schema, because the schema is quite simple. We're going to think about how we schedule things in regardless to time zone and carrying events. Also, we are going to talk about atomicity and reliability, like the retry logic, prioritizing tasks based on priority, um, and also do a small CRUD app to demonstrate this. Um, yeah. So what you're going to build today is like a reminder type of application, and see how you can create recurring schedules. So think of like reminder apps on your Windows computer or mobile phone, which does something similar to this. Something cool I'll talk about is the time zone awareness, which um, I have encountered it at the job I'm working on, where we had a bug where for some reason someone forgot to make sure that how we are tackling dates in the application, um, it is time zone aware. So when I mean time zone aware is if I create a schedule in East African time and the app is deployed in, let's say, East US, so East US time zone, how are those times going to be dictated by the application? Will it be observing our EAT time? Will it be working with the Eastern US time? Those type of questions you need to think about when you're creating any application that is time zone aware. Other things are like automatic processing. We shall see how this is good. And things like priority and how you can do this even in your Docker machine. So we're still using Nest, Mongo. We're introducing a new library known as date FNS TZ. um, and the rest are the same. We're using TypeScript 6 to be honest, but 5.7 will still work. Document DB Nest Schedule. That's a new module which I integrate into our Nest application further. Then Docker Compose to spin up the database and sort for schema validation. So when we speak about task scheduling, I'm thinking of this app like you have the ability to send reminders, and then these reminders can, the app we are not going to tackle where we're going to integrate with emails, but you can add that and make this a real application. So we'll be thinking of how you can renew a subscription which is ongoing, how you can clear expired sessions, and do retry on some few things, right? Even how you can think of creating a payment processing application, and also add these task scheduling things. So this is the biggest slide we need to understand, because if you understand this slide, then this call is over. You'll be done with this call, and you'll be happy going home. So whether you're using Nest.NET or any type of libraries or frameworks, you'll come across these 1, 2, 3, 4, 5 stars. So these 5 stars, they represent days, months, hours, and minutes of how you're going to schedule a task. So when I say a task is something like a cron job. So a cron job is a scheduled task that runs automatic based on the time that it has been scheduled and the cadence, that is the interval for this. So for example, the first star, as you can see, you shall see in the code base, it represents the day of the week. So the day of the week, 1 is Sunday, 2 is Monday, 3, 4, you get the point. And then we have months, where 1 is January all the way to the 12th month, which is December. And then we have the day of the month. So these can be day 1, day 2, day 3, all the way to 31st. And then the last one, or the second last one, is hour of the day. So this can be the first hour of the day, second, third, fourth, all the way to 23 hours of the day, or 24. So 0 is the first one. And then we have minutes, where 0 is the first minute all the way to 59. So with these, if you are using like Nest, like we are using, you find a decorator known as @cron, which will say the numbers we shall add here will dictate how this function is going to execute it. When I mean executed, is run. So if we say something like, hey, star, 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 this function is going to be executed every minute. So after 30 seconds, it is executed. After that second, it will go that, doing that forever. So we also have like in the first star, if you say like the first star divided by 5, so it means that after every 5 minutes, it is going to be executed. So if we say the first star is 0, that means that after every hour, it's going to be executed. So in a day, it is going to be executed 24 hours. Okay. So if you want to go to like every day at 9 a.m., so as we said, the first one will be at 0. And then we have to give the time. As you can see, we have not time, but hour. When I mean hour, I hope I'm not confusing people. So every day at 9 a.m., remember it's 9 a.m. because we have 9. If you want to make it p.m., just do 9 plus 12 and then add that number here. Okay, so that will be in p.m. Cool. So if you want to do these like in every Monday, so you can skip the day of the month, and skip the month itself because this is going to happen every month. Uh, and go to specific day. So day of the week. So this is going to be at 9 a.m. Of every day, specifically on not at 9 a.m. of every day, but at 9 a.m. of every Monday, this function is going to be executed. So if you want to be like specific, like uh, um, when can this happen? Let's say in a month. So you're going to go to this asterisk, which should be the day of the month. And as you can see, if I say 1, it means on every first day of the month at 9 a.m., this function of ours is going to be executed. So if you want to do it every day at 8 a.m., this is how it's supposed to be. So if you're going for PM, as I said, you just need to convert this into PM by adding +all to do that. So you'll find that most people won't be going for like executing something with precision, like at 2 p.m. on February 2nd, date 2 of every Monday. When that lines up, that's when this function will happen. It's when you're using all their stages. Most people will be doing like after every 1 day, after every hour, after every this on specific week. So the first like 1, 2, 3, 4, 5, 6, the first 7 of these options, you'll be using them quite often. So if you understand that, then the rest is just implementing it yourself then. So for example, on this side, as you can see, we have like a client type of application where you can just send requests to our API, and this can be a post get batch. And then we have like a service to execute different methods. So our node code decorator, we're going to add it in the service because this is where we want like a specific method to be executed after a specific duration. So this will be like how you can think about creating an architecture of the system you're working on. So you need to think of where the scheduling module will happen. So for ours, we already know it is in the service layer where we're going to have at Cron. So where we shall specify that. So, and then on the other side, as you can see, we'll have an app module, which is the module of application, database module to connect app module to our database, and other modules will have access to our database. We'll also be doing reminder module, where you create a reminder, update a reminder, delete a reminder, those type of things. And then the scheduling module will be called by the reminder module to check some feelings. For example, let's say someone creates a reminder to remind him to study something in the evening today. So that request will come from the request reminder and then be passed to the scheduling module, whereby the scheduling module will create that, will spin up behind the scenes, it will spin up a process which will be doing the work of a cron job. So with that in mind, I think we are in a good place now to discuss some few things. So this is how we are going to architecture the data we need to create this app of ours. So we have a title message, due date, status, time zone, is it recurring? What is the recurrence pattern? So this is the cadence I'm talking about. So, sorry. So the cadence can be daily, every hour, it can be every hour, every minute, every second, daily, weekly, monthly, yearly. So that's cadence or the recurring pattern. So we can also check the occurrence count. So how many times it's going to occur. Priority, is it of highest priority or less priority? So you can do that with a range of 1 to 10 or 1 to 5, depending with you. Did it succeed? So let's say failure attempts is just a robust way of checking whether something has been executed and it was successful. So it was not executed and successful. Should we retry it like 2 times or 3 times? So these are what we do with max retries. So the number of time you want these to be retried. And if a retry happens and it fails, you save that into failed attempts. Okay. So the status lifecycle, this can be pending. When you create a reminder, it can be pending, active, sent, or failed. So this is something you need to think about in general when you're creating these type of systems. And here we have an example of how that type of data will look like. Okay, so how are we doing this? So step one, you query the due reminders. So you know the app will be running and it will be checking, hey, do we have some due reminders which we haven't reminded people? So the status of that will be pending, and the due reminder will have to compute some dates here and there. And then after this is done, we go to processing each reminder. So if there's a reminder, we need to tell people that they need to do something. This will be the same. We shall see some logs and then send a notification. For this case, we'll be simulating, but you can go ahead and implement these and use things like web push. There's a library known as web push, which you can push notifications from your web application to your Windows or MacBook or whatever operating systems you are using at the bottom there. So send notification, find one and update, and then we shall see this in the logs. So before we should see something like this, status pending and due date is this. It has been sent. We should see something like this. Yeah. So basically what is going behind the scene when we have recurring reminders, it's simply, let's say we have a timeline of doing this, reminding people on at 9 a.m. daily. So these, when we talk about occurring reminders, we mean like the amount of days we need to redo this. So if you have a job or a task that you need to be reminded every day, if that is a recurrence pattern, it means that we shall do something like we query the data, we process and see whether we have a due date, and then if that's not the case, we update this. And this should be the thing that is happening behind the scene. So query, process, and update until we find that day that you need to be reminded. And if it is today, tomorrow, and the other day, that should be the case for every day. So supported patterns, this can be minute, so every minute, hourly, daily, weekly, and monthly. So this can be the uh, occurring cadences. So time zone support, these are a little bit tricky, but easy if you know how you're doing it. So the trick is simple. Every time you're saving the dates, you need to save them into the UTC format. Okay. So the UTC format will be easy to be converted to whichever date time zone you want to work with. Okay. So there is a library known as date FNSTZ, which is so cool at doing this. So let's say you have a client who is in New York at 9 a.m. So this date FNS library will take this date, convert it into UTC, save it in the Mongo DB or whichever database you're using, and then fire a cron job using the UTC. So if someone else is getting this reminder in Europe, this UTC time will be converted back to the normal time in whichever time zone he is, which is the trick. So if you do it other ways, you might be able to achieve the same thing, but you'll have to write a lot of code. So this is like the go-to simplified way. Saving the date in UTC, converting it into whichever time zone you want, depending on how you have architected your application. So when you talk about atomic updates, so this is where we want to prevent duplicates. So let's say a cron job reads the status as pending, and then we have another cron job reading the status of the same cron job as pending. So that's a duplicate, as we have seen, because what will happen if it does that, it will send the same notification twice. So you can think you have, let's say Microsoft Teams, you have scheduled a Teams call, and then we have someone who wrote code in Teams this way without thinking about atomic updates. So what you're going to get is you're going to get double notification because double cron jobs ran and they fired two events. So this type of issue is known as race condition. So race condition is where you're getting duplicates because the system is not well oiled or organized. So it is like a vehicle which is just moving. You have some parts falling apart now and then. So when you're creating your code base, you need to think about atomic read, modify, and write. When I mean this is, let's say you have created a job of reminding you that at 7 p.m. on every Sunday, you need to get a notification to join the Kenya Data Platform meetup call. So you want to update that time should not be 7, it should be 7:20. So what happens is that you need to make sure your code is well organized. It's atomic, that's what I mean. It's atomic that it is going to find this cron job and change that particular part, that is the time. Not everything, not wipe everything. What do we call this? Is it put or patch? It should be patch. So you should do a patch rather than a put. You know, a put you're going to like recreate or update the whole object. So you should do atomic, like a small update in the way you have structured your application. So this will avoid the occasion where someone deleted the job and recreated the job. And then those two events, one fired an event to say, hey, this job is deleted. And then the second event fired to say, this job has been recreated. So those are two events. So when you're creating these, you need to think of atomic modifications, no race conditions, no duplicates, and then things like when you're processing your data, you also need to think of retry logic and those type of things to make sure that you account on the failing jobs and the successful jobs, and how many times these failing jobs were retried. So yeah. It might sound complex, but it's easy once you get it. So these will be like our endpoints, get our reminders, create a reminder, get a specific reminder, update a specific reminder, delete specific reminder, check the status of reminders. So pending or sent. Simple. So speaking about how you should do this. So in our project, you can just cd to this project, do npm install. Once you get the code, um, add some environmental variables according to your code, because you have to store everything on .env, and because you'll be using, let's say, Docker, you need to create like the database URL there and run the application. That will be the easiest way to get this code running. So let's go to the live demo and also discuss the code as we do some few things. Any questions so far? I haven't been checking the charts. Do you have any question? Do you have any questions so far? Okay. There's a Q&A on Teams. There's a Q&A. You can ask your question there. I can see we already have some few things Michael has ongoing there on our conversations on the Q&A. So interesting. Nest allows you to set the time zone for the Cron. Cron 00 this helps a lot when you do not want to do calculations on wherever you're hosting the server and what. Yeah. So we shall see how that is easy to do. Again, Nest has these things known as decorators. So there is a way they have automated this process, where even you don't need to add like zeros and ones and eights, but you should know how to work with that. That's why it's important to understand the fundamentals of cron jobs. Like as I said, the honest right, which I talked about, you should understand and we discussed in details. Once you get that, you see other things that libraries try to automate and make them easy to just do. So we have talked about a lot of things. Thank you, Michael, for that. Yeah. So if you have a question, you can just use the Q&A or unmute your microphone. Yep. So what else did I want to us to see? So this is so hard to make it small, but I think we have. So this is how our API looks like. So we'll have the front end can be Postman, car, whichever you're using to send requests to the API. And then we have the API, which has two modules. Specifically, we have three. One is a database module, but two of them, we have a reminder and a scheduling, which is very important. The reminder will be creating the jobs there. Let's say I want to be reminded on Thursday to do blah, 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 that. And then the scheduling module will be called inside the reminders module to either query the reminders or process each reminder or update the status or do all those background type of processes. So if you think about these, even in other systems, in other applications, this is how mostly you'll be thinking of designing an application that requires cron jobs. You'll be thinking of a scheduler and also just a normal CRUD type of reminder or something like that. So this is how we're going to do it for our case. So in this README, you'll see different workflows. This is again. Okay. So these are some of the workflows. You can just go and read them. I've tried as much as possible to create them. So when you create a reminder, it will go with the title, message, and due date. That will hit this part of the API, that is the control. Zod will validate that. If the validation says okay, that will be taken to your service. Service will still validate this based on the DTO. And then once that is okay, it will be inserted into your MongoDB or whichever database you're using. For our case, we're using Document DB, which is compatible with MongoDB. Hence, we're using the MongoDB driver. Then once that is saved, it will of course return some status to tell you that that is created. And then the cron job will pick up. So cron job for our system, it will be running at every minute. So after every 30 seconds, it will be checking the things that have been done. This is not the most optimal way of doing this, but this is just a simple pattern. So the cron job service or module will be just be running every 1 minute, and it will be checking. So do we have a due date or due reminder? Yes. If that is found, you shall see them on the logs. But at the same time, if you have like an emailing system or a notification system, that should be fired. Like, hey, you have a reminder to do this at this time. So if it is according to how we have done this, I'll show you in the code. Even after checking every minute, there is also due time. So do you want to be reminded 5 minutes before this thing happens? If your due time is 5 minutes before, then you should get a notification like, hey, in the next 5 minutes, you're supposed to do A, B, C, D. Yeah. So at this part is where you hook those things, emails, notification type of systems. Yeah. Other than that, the rest is simple. The use of this recurring reminder flow, as I explained it, these diagrams are way, way easier to explain. Yeah, so time zone, how we are handling this, I also talked about this, converting to UTC, and then from UTC, converting back to whichever time zone you have. And you don't have to do this manually. There's this library which is used a lot for that. So cool. Let's dig into the code and see. So as usual, we have our normal code base with us here. Just mute some notifications here. Okay. So we have our normal code here where we have our source folder. This is a normal Nest application. As you can see in the package.json, we don't have new libraries, except we are going to use NestJS schedule, and then what else? Data finesse. Yeah. Other than that, the other things we have been using them in the previous course. So in the Docker Compose, we just have one image for Document DB. And in these, it's going to take username as admin and password as password. Nothing else. The rest is just a command that will be pinging the database after it is created inside the Docker container to see whether it is available. This will take like 10 seconds. And then we have even the retries. Okay, this other is just a Docker file to build the next application if you want to build that into two containers, one for Document DB and then the other one for the API. So simple as that. Other than that, we have our app.http file, which I have documented, and it is going to help you just run this app and execute some endpoints without having to type them manually. For that, you'll need an extension known as REST. Oh, sorry, known as REST. It's REST client from this guy. Yeah. So with that, if you create just any file like app.http, it should just work by sending this request. Okay, so in the source file, as we have been using our folder structure, we have our common things. So these can be decorators, pipes, schemas, anything that is common. When I mean common, it can be used in different modules. For our case, we have our modules inside the module folder. So we have a reminder module, a scheduling module, and the database, you can put it inside here too as a database module. So inside the databases, we have a module file, which if you're new to Nest uses this module-based architecture. So where different files are organized into modules. Okay. So at the root of your application, we have app.module. So app.module is like below it, you can have different modules doing different things. So for example, in this case, you can see under here, we have database module, reminder module, and scheduling module. Okay. So these are the three modules. One is here, and the other two are here. So when I mean other three is reminder.module. So these modules, what do they do? So for example, a reminder module will make sure that a controller is able to speak to a service, and even both of them, they can be able to speak to the database module, so other modules. So that's the work of the in a module. So as you can see, it is importing scheduling module because we need to use a scheduling services inside our reminder module. And then it has its own module, its own service, and then it is exporting the remainder service. That's its work. Bring some few things and then export everything. Cool. So let's start with this. So we have some decorators to help us with validation. So we have body, query, and param zone decorators. We also have a pipe to enable Zod to be used in Nest. So this is going to be deprecated. I'm going to create a code to show you the latest features of Nest, which helps you to eliminate these two files. Yeah. So other than that, we have a schema. So we have this common schema, which is object ID. So if you know MongoDB, it has this weird object ID requirement. So if you're sending any ID, even if it's a variable UID, you have to convert it into this object ID. So for this, I created this object schema to make sure that it's reusable in everywhere where we need it. Yeah. So it's just going to pick a string and then refine it using this object ID from MongoDB library. Yeah. So since those things are well understood, we also have utilities like date helpers. So as you can see, this is just something to help you deal with dates. So just go through it. I've tried as much as possible to make it simple, and also it's well commented. Recurrency helper. So this something you can change. You can make it even more than this. So that's the pattern. And then we have these functions to help you do different things. So for calculating daily occurrency, hourly, minute, those type of occurrences. Yep. We also have time zone, which we are using datefns, datefns. So this is going to help us with passing the date. So passing from one format to the other, so that our time zones can be well understood and respected. So again, this is well documented. I don't have to go line by line explaining date functions. It's something you can just go and read and see. So other than that, database module, we know what it does. Database service, it will help us to just create a simple class and a connection out of this. The important is on module init, which is a Nest default module, which helps us to execute a specific function before even the class is executed. Okay. So for example, here we're just setting the client with some different things. So we are getting the connection string from .env, and then we are creating a Mongo client, and then we are connecting to it. So out of these, we are creating a connection. And then out of this connection, you can have also a module destroy. So every time we end the usage of the module connection, the MongoDB connection, you can just destroy the connection. It does make sense. So let's go to creating reminders. Yep. So inside creating reminders, as we said, we create details to help us validate the data coming from the user. Okay. For this, we are not using class validators, the OG Nest class validators. We're just using Zod to create a schema and then validate it and then export the type. Okay. So that's details. Schema is simple. It's just how we are storing the data. For our case, we have some enums, like the status, we have an enum type of thing. Let me call it enum. So it's storing something like pending or sent or active. So it's like an enum. That makes sense. We have priorities, we have a lot of things, but this is the only thing we need. So it's like the only table we need. Okay. Call controllers will receive different requests. As you can see, there's a lot. We have create request, find all. We also have find pending. We also find sent, find active, find high priority, find medium. You get the point. And something you see consistency is that we're using the Zod param decorator to validate our parameters or the URL params, whether they are of type object ID schema, which, as I said, is a common schema for us here to check. So even if you're passing an ID, is it a valid MongoDB object ID? Yeah, that's the case of the Zod params. So it's common. We also have a Zod body, which is a decorator. It's going to validate between the data you're passing for updating versus the schema, which is update reminder TL. So the one we exported. So if your data is not following this, you'll get an error. Okay. So we have those validators with us. What else? This is just a healthy to check whether the API is running. Yep. Cool. That being explained, we can jump on to the service for the reminders. So here there's a lot of code. We have, let me just minimize this first. Yeah, so we have this. Simply this is just a Nest class with a decorator injectable, so means it can be injected. In other terms, it can be extended, it can be used in other classes. That's what it means. So it's a reminder service class that implements one module init because we'll need to initialize some few things before they are being used in the methods. So on module init, we are getting what? So here you can see we have a collection as a private method. A collection in a document DB is basically like a table in SQL databases. So, so we are getting this collection from type reminder. As you can see, we are typing it here. We're using this shebang because we just want to tell TypeScript that these will be ready for the module init. So if you remove this, you shall see some reddish line telling you that, hey, this has not been initialized, but in Nest, we can do this because it will carry some value after this is executed. So yeah. So what are we are doing? We are creating some indexes. Why? Because think about it. We have a collection which is being pinged every time. So we need some indexes to kind of help us traverse. If you've ever thought about how data is stored in a database, the process is not just us saving something or fetching something. So there's some things which happen in between, like traversing, I don't want to say a linked list, but it's more like a data structure. So there are some algorithms that are used to check, should I insert data in the bottom or the top or wherever the database is built on top. So creating indexes will help your application perform better because now the database will be aware of where it needs to save something, update something, and make some few things easy to do, like querying data, checking data, those type of things, filtering data. So indexes are quite important in SQL and non-SQL database. So for this case, I'm creating this type of indexes for status and due dates and those type of things and priorities for filtering. I know this should be done at the schema level, but since we are not using an SQL database, it's tough. Using an SQL database, you have to do this in the code. If we were using like Postgres, if we were using Postgres, I would have used these inside our schema, which, let's say you're using something like Drizzle, it should be persisted to your database. But for this case, I know we can do that in this schema, but it's just good in the service. Okay. So let's say we are creating a reminder. So what is the process? So we get the current date. So which is this date? So this will be the date where the server is deployed or where the server is running. Okay. So if the server is running on Azure in East US, let's say it will be taking that time where it is specifically deployed. If you're just running it locally on your machine, it's what is happening, the time zone you are in your local machine. So then we are going to check for these things. Do we have a recurring? If it's not there, put it to false. Status is pending by default unless it is given. If it is given active, we go with that. We're also going to calculate the next due date based on the recurrency. So if we want this reminder to be fired after every 20 minutes, so we need to know the next due time. It should be time and date, but time if that's the case. If the next reminder is next week, then we can calculate days and dates and time to be specific. So all these will help you do that. Remember, these are the helper functions we created and utils for that. So once we have this, once we have our new due date, we can go ahead to create the reminder. We are going to omit the MongoDB ID key. Then we pass this data. Time zone support do that. So basically, we just say our data as UTC. Check for currency. So if there's one, we make sure it's there. And then we execute the insert one, which if you're in our previous code, this is a MongoDB query method. So MOQ. So insert is just insert, yeah, till insert one to um, our database. And then we are going to return this. Okay, so find one, it's going to find. So this is easy. It's just going to find and say whether it's there. Update is the bigger one. So we should be able to update by just spreading the data we want to save. And then we shall use the update one and use the set operator to do the updating in our collection. If you're struggling with this, I would highly recommend you to watch our previous call where we were doing a CRUD type of operation using the Mongo query language with Document DB. So remove is just if the ID is valid, yes, go ahead to delete. If it's not valid, throw an error. If the results are there, return them, or yeah, if the results are there, we should return them. I think we are missing that. But if they are not there, just throw a not found exception. So this looks good. Let's talk about scheduling, which is important. So we have an interface where we have like different metrics we can show on the console. So they are like DTOs, but since we don't have a controller, we can't call them DTOs. They're just interfaces. So we have a service. So as I said, we have this back of schedule. What else? So this is just a class. We have a lot of metrics which you can show as a private method. We need to get the database connection on module init. So we need metrics, we just return the metrics which we have. What else? This is a private method to create the next retry based on back of schedule. We also have handle something on failure. Oh, I was looking for this. This is the most important piece of code here. So let me just minimize the rest. Because this is the only cron job we have for this application. Because as I said, it will depend with the application. For us, it is a reminder. So we need just to spin up one cron service, which will be checking things based on the data which is in the database, which is a better pattern. Instead of having a lot of cron jobs, and then let's say even you're not persisting your data, and then you have inconsistencies. So think about this. We have reminders and the time they were created and the time they need to be reminded and the reminding cadence inside our database. So what do we need? We just need one cron job, which is just spinning maybe after every minute or whatever time you want. And it is just doing some comparison based on the current time and the data in our database. And then with that, it is processing different reminders or alerts, whichever you want to do with that. So we have this at Cron, which is a decorator coming from NestJS schedule. And also we have the Cron expression. If you control and click on this, this is how you know what types are there inside these decorators or anything in TypeScript. So if you control and then click on this, you should get this enum.d, whatever. And you shall see the different things that Nest has done to make your life easy. So you don't have to always write the stars and maybe mess up something. You can use these enum things which they have created for you and the equivalence of this. So this is a good thing to use. which is more readable, like on Monday to Friday at 4 p.m. This function will be executed. So you don't have to think about that as 0004, 1 to 5. Yeah, it's simply this. And also this, you can use this to learn more. You can actually use this to kind of learn more things. Yeah, or come up with your own Cron expression and use it as a decorator or something like that. You can modify this to your application. And instead of, you can modify that into the needs of your application. Instead of using their type from Nest schedule, you can actually create yours with the times and things you need as a type or as a schema and use it here. So this is cool because now what I was saying is that every minute that will be executed, if you just do dot that, you should get all the types we were talking about, like when to execute this. Yep. Else, you can remove all these because if you hover on at cron, you should see it is accepting a cron job. So these also you can pass it as just um, the aesthetic, the native way of doing that. So yep. So what is inside here is simple. Start time now. So meaning every time we are creating a cron job, it will start based on a consistent time and time zone. So the other things are just simple process both one time and recurring reminders. There's a little bit of math here going behind the scene, like checking which reminders has been processed, which ones have failed, which ones are upcoming, and if there is one that is supposed to be processed, it is processed. So you can make this better by creating a queue. Okay, you can create a queue system. Where is Michael? No, Michael is quite interested in these things. So you can create a queue to kind of make this better, okay, and process things as they come. So you can use like a fast in, fast fee for fast in, fast out type of algorithm to do this, and maybe you can even do more by persisting that queue into like a Redis type of database and have a very solid um, processing there. Yeah, cool. So I know time is not on our side, so let's just do a demo of this. So for this, you need Docker to be running. As you can see, Docker is running. And then we have our Docker compose. You can run the command, or if you have some extensions for Docker. If you have this container extension, the container tools from Microsoft. If you have this enabled, it will help you execute things just on the Docker compose file. Like if you want to run this or run this service. So I want to just spin up our database. So I just need to click run service. And that is just like Docker compose up and blah, blah, blah. Yeah. So it is going to spin up a network and a container. So if you check on the containers, you should be able to see we have this now running our database. Yeah, just cool. So yeah, so now that we have our database running, I think we can spin up our application. So okay, so this will be npm run start like that. So as you can see, our app is running. It's running on port 8000, which is a good sign. Okay, so the next thing is to go to app.http and execute whatever you want. Okay, so let me just minimize this. So let's see whether we have reminders and those kind of things first. Okay, so at the bottom here, you can see the get type of, sorry, it's on top. Yeah, so here you can, yeah, what is this? Generating a reminder. Oh, as you can see, we have no new reminders to process. Cool. So the cron job is already running. Um, but let's see whether we can get or get sent reminders. So let's see, send these, we get empty. So there's no sent reminders when you start this application. Okay. Um, get pending reminders. Send these. We have none. Okay, which is cool. So let's create a reminder. Okay. So I want to just by creating the first one in this file. Now button a lot. So yeah. So this was checking whether the app is running, but there's no endpoint on that. Yeah. Maybe it turn on. Anyway, create a reminder. So we have a reminder with us, title, message, due date, status, priorities, medium by default. If you don't pass on, and status is pending by default. So at the bottom, I want to see what will happen. But I also want to see whether we have reminders with us. So I'm scrolling back. I'm just lazy. Get reminders, send this. We have one. Okay. Let's try to get pending reminders. Send this. We have one. Okay. As you can see, reminder processing complete. So one processed. So if I send again, like pending reminders, we should get 0 because the remainder we had has been processed. Okay. So where is it? So if it's not pending, it should be under what? Sent. So let's send this. And we see that one reminder has been sent. So think of these if you have something like, hey, you need this to be processed via an email. So that means an email reminder has already been sent. That has happened automatic because after every 1 minute, if there are reminders which are being created, they'll be executed. So it's more like a queue if you think about it. It's only that we are not doing some crazy magic of creating, let's say, like the way I was saying, like using Redis to kind of control this queue and blah, 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 and do those type of things. So as you can see now, we have module reminders. Good. But I hope you guys get the pattern. The pattern is quite important than crazy architecture ideas in your brain. So if you have like a simple pattern which you can use to create something, it will be way, way more useful to do something. So let's create more reminders and see how this goes on. I want to have these open so that we can see. So we have already created one reminder. I think it's this one, right? But um, create another one, create another one, create another one, create another one. And probably create another one this afternoon, one midnight, one at noon, and one past due day. Okay, and let me create one for future day, one with minimum. So you go and read about these things. If you one missing title, this should fail. As you can see, validation is working. Um, one with an invalid, too long, whatever. So send these, should also fail the title. So validation actually is working. Okay. So let's get reminders. All the reminders are there because they have not been processed. Remember, this will take a minute. So after a minute, all these will be processed. Okay. And being processed, as we said, it will be not hard to understand. Let me not repeat myself. Get pending, send these. Pending is these ones. Okay, they have not been processed. Sent ones. Oh, we have two completed. We have two processed. So let's see. Pending. We have one pending. Sent. Oh, these are all. Where is sent? Sent. We have 1, 2, 3, 4, 5, 6, 7. So it created a lot. But you get the point. Any question? So you can also do CRUD. CRUD is working automatic, by the way. If I copy that ID and paste it somewhere where on top here. Come on. Is yep. Let me try to make this ID bad, like delete D. Let's see whether we get validation for that. So for example, if I try to fetch that ID, it's here. So if I try to fetch that remainder, send this, we get an error. So invalid object ID. So our validation is actually working well. Okay, so let me make this back. Try to fetch it. Send this, we are getting it. Yep. You can also delete it. So send this. Yep. So it's deleted. Any question? Comments, reminders? Send this. Reminder not found with this ID. Yep. We're extremely silent. But this is very effective. If a cron job is running every minute, you have like 1,000 reminders and those things. It can be way, way cheaper in terms of computation. So we have Kiprangat with us, Simon, Bernard, come on, Rooney. Any more questions, guys?
Hey, Kevin.
Yep.
Am I audible?
Yep.
Okay, so just when you were mentioning about the cron running every minute, it got me thinking, like isn't that like polling but like manual? Like okay, I don't know, like an automatic way of poll. It's like could it have been any different if Kamatungetumia event driven, where if something is posted and then you can just, if that event happens, something else initiates or activates? Or what is the essence of running the cron every minute?
Again, as I said in the beginning of this call, it will depend with what you're trying to achieve. So, basically, cron jobs are like polling because you're executing something after a specific interval of time. That's what polling actually is. It's only that polling happens in the client phase part of the application, where after every something it's pulled. But also you can do it in the backend. But in the backend, if you're calling it pull, that is more of a cron. That's my understanding of those terminologies. Because let's say I want to fetch data from a database after every 30 seconds. If I'm executing that type of action in the front end, that's pulling. That's how I think about it. If it is in the back end, that's a cron job. To your next question, can I remember? Remind me the next one. You talked about something to do with executing something after every 1 minute.
Oh no, it's just that I wanted to know if you are running the cron every minute, so that is fine. If the spelling notifications, well then if a person made a notification, you could have. I was thinking that for you to use an event-driven architecture where a person posts a reminder, and then the reminder gets saved in the database, and then now the cron just checks the database. That was
Yeah, yeah, yeah.
the question.
Yeah, you can use, by the way, you can use an event-driven architecture. It's only that this is not an event-driven type of software. If you think about it, if it's an event-driven type of architecture, we'll be more into like a microservice thing, which was not beginner friendly, to be honest. For this call, if I could have started with microservice type of solution, it will be more complex. But I get your point. Yep. So that is all because you can optimize this into that. So every time you create if you create a reminder, that should trigger a schedule job to happen automatic, and then you still have like a reconciliation type of cron job which is running, because um, creating a reminder does not necessarily mean you need that trigger to happen now. Okay. So the way you're putting it, the assumption is that when you create a reminder, uh, the cron job should happen immediately, which is cool, but what is the cron job helping you with? So if your goal is to notify the user immediately, that's so cool. You can just do that. If you're waiting for pooling, or not pooling, think of this as batch processing. So if you're waiting for like 30 seconds to process all the reminders that has been created by the users, you can go with this pattern. If you want to do that immediately after the reminder is created, then you can go with an event-driven architecture. So again, it will all depend with the cost of computation versus the architecture decisions, which you senior developers are going to decide.
Yeah. That makes a lot of sense. Thank you. Understood.
Yeah. Which is a tough decision, because you'll find some developers, maybe you're working with them, they're like, no, let's go these. So if, for example, if your software is not a microservice software, you cannot come up with such an idea, because it will mean you have to rewrite the software into that architecture. So is the pain of rewriting this whole software versus one feature worth it? If that's the point, yes, go ahead. But again, let's say you have now a microservice type of application. That will be the easiest decision to make. So that's why software engineering is hard. The hard part is, I know I sound like those guys who are advertising AI. The hard part is not always writing the code, is thinking of how you're going to implement the idea. Yeah, I know I sound like a salesperson from Anthropic, but I'm not. I, yeah, I have a subscription, but I'm not from Anthropic. But but think about it. Decisions are the tough things. So I remember I was given like a spike ticket to investigate something, which I'm not going to say, at the job. That was the toughest thing to do. Spike tickets are tough. I don't know that you guys have ever come across a spike ticket. A spike ticket is a research ticket where you're given, let's say you're told, hey, Michael, you seem to be more, knowledgeable in these low-level things. So can you go and investigate how we can create a CLI tool to kind of correct everything that is in the logs and I don't know, automate that with an email or an AI agent and come up with the recommendation. Bro, and then let's say the Scrum Master will vibe code, not vibe code, will ChatGPT some of the solutions based on that ticket. And then you'll find that that is part of the AC, the acceptance criteria of that ticket. So you find that 90% of whatever is written there is not going to work. So your work is going to research and come up with recommendations. That's where you know that coding is the easy part, because that research of yours should come up with solutions. And then after you have done that, you hear, oh, now Michael, go ahead and create a POC of your solution. So you are there now sorting because you gave some feedback, or you gave some feedback which are not POC radio. You can't do it. And you've already given this is what is supposed to be done here. So that's when it becomes tough. And you remember, hey, think coding is easy. If just someone tells me, hey, create this CRUD type of thing, that's the easy part. I think doing research and recommendation and creating POCs of things which are out of the scope of the application, that's a little bit challenging. It will take more than just writing the code.
Hey, can I ask another question or make another
Yeah,
comment?
yeah.
Okay. When you look at my Q&A, you'll notice that I wrote a comment there saying this is low-key like a message queue library. I think it's interesting how you are able to sort of, are you like you're using an algorithm to decide which tasks run first and which ones run later, and then you're also putting them in the database, but as well you're cleaning them out once they're done being processed, and then you're putting them in another section where it shows the ones that have already run. I think it's a cool thing. I will probably try to build one as well, but I'd have to look at your code later when you post it. But do you mind explaining just an overview of how you did that, how you were able to run the, so like you're figuring out which tasks to run first, like a FIFO or something I had you say, and then after they run, you're cleaning them out but still preserving the fact that these tasks ran and these ones are yet to run, and the ones that have already ran you delete them from the database. So yeah.
Yeah, again, it's all about an architecture type of decision which you just come up with. So for example, ours, if I just check on the schema, it should tell us everything first. Um, so yep, so with this guy, it's visible, yeah. So so what I did, Michael, is simple. Okay. The way this is done in an SQL database, it might be way, way different from what it is done in SQL database. Or you might do it the same way, but struggle in one or the other. The reason why I put this call in our document DB, it's because it's so easy to do this. You know, it's crazy when you do this in an SQL database. They'll be like, hey, why are you not respecting the ACID, wherever's in SQL? And well, you need to normalize this, okay? But in an SQL, in a non-SQL database, this is not the case. So what I did is, as I said, how do you know what to process, when, and how, and what is the cadence? That's the beauty of coming up with uh, something like this. So what you're saying in front of you is just a data scheme, which will help you to architecture your application the way you want. At one point, I have these enums which are helping me make decisions. For example, the status, the priority, and the recurrency pattern. So with these, what else do I need? I need, for example, I have one cron job. This one cron job, it is like an autonomous type of function, which is helping me do different things based on every minute and based on the data I have in the database. So if I have data in the database which has high priority, I need to consider that and make sure that those records are executed fast based on that priority. Every time I execute something, I'll make sure that I updated the status from this to that to that. Okay. The recurrence pattern is how many times do I need to deal with this data? Is it every minute, every hour, and the rest, as you can see there. So I'm using one cron job to do a lot of things. Other people will go with a pattern where you have several cron jobs these cron jobs being like, hey, this cron job is executed um, based on the status. This cron job is executed based on priority. So you can go with that type of thing, and then you won't have like one data, one big object which you're storing in your database. You'll have like small objects based on different tables. So again, Michael, I don't know how I can put this in simple terms, but you get it's about the data and the decision you want to take from there. So um, so for these, you see, like I have a queue from nowhere, and this queue is backed because I have a database, and then I have something that is being done after every 1 minute, which is deciding what should be done at what and when, on how, what, you know, I, it's like that. So again, as I said, someone will come up with like a better idea how to do this or a crazy idea. It all depends with uh, what you want. But again, even when you're creating softwares in your company, the only thing that will make the guys who are above you smile is when they hear that a problem will be solved without incurring extra cost. They think you're very senior because of that. So, for example, in this application we are creating, which is just a reminder, if you try to tell them like, hey, we need a Redis um, caching database, we also need to rewrite this whole application into a microservice and then do A, B, C, D. People will be like, that's a work for almost a week. Why should we do that? It is more expensive. And then a product manager will tell you, hey, you mean we provision a Redis database? That's expensive, man. Give us another solution. So for the easiest way to do something is find like the optimum solution, which probably won't cost, or it will be the least cost, the best cost effective way to solve a problem. That's how I can answer your question. Michael, have I answered your question?
Yeah, you answered it kitambo.
Oh, okay, okay. Maybe I was just ranting the other part. Is this Anthony? Let me stop the recording.